fundamental theorem of calculus. The fundamental theorem of calculus will only work for a definite integral. Okay, and so if you look here, theorem 4.9, it says if a function f is continuous on the closed interval and f is an antiderivative of f on the interval a, b, then the integral of f of x from a to b equals f of b minus f of a. So basically what's going to happen is you're going to integrate f of x. When you get that integral, you're going to plug it into b, the top limit first, and then you're going to subtract from that the value at the bottom number. Okay, so let's look at an example. And you're going to see it's really not near as bad as it looks. Okay, so this says evaluate each definite integral. So you already have this written down on the sheet I gave you. And so now what we're going to do is we're going to integrate x cubed using our x squared, sorry. We're going to integrate x squared using our integration techniques. What will x squared integrate to be? X cubed over 3. Minus, what does 3 integrate to be? 3x. So now what I'm going to do is I'm going to put some, like a little bracket thing there, and I'm going to put the top number on the top, the bottom number on the bottom. And so this is from 2 to 1. And so now what I'm going to do is I'm going to plug in 2 first, since that was the top limit. So if I plug 2 in for x, I get 8/3 minus 6. Then I'm going to subtract from that what I plug 1 in to be. So 1 will be 1/3 minus 3. Okay, so 8/3 minus 6 gives me negative 10/3. 1/3 minus 3 gives me negative 8/3. I think. Double check. Does that come out correct? So now if I combine those two, I get a value of negative 2/3.
Oh, I forgot that negative sign. I would have been right. I forgot the negative sign.
So then now what that means is that the value underneath the curve, x squared minus 3, from 1 to 2, is going to be negative 2/3.
Okay, Lucy, did we ever finish learning 4-3? I thought the last half of 4-3 you said we still learned. Oh my gosh.
Okay, so let's go ahead and look at this one. Okay. We're going to evaluate 3 root x from 1 to 4. So first of all, let's rewrite it. 3x to the 1/2 dx. So if we add 1, we get, so x to the 3/2, and then what am I going to take that times? 2/3. And then I'm going to evaluate that from 4 to 1. So let's go ahead and cancel our 3's. So really I have 2x to the 3/2. Evaluate it from 4 to 1. So first thing I'm going to do is plug in 4. And so I end up having 2 times 4 to the 3/2 minus 2 times 1 to the 3/2. So if I take 2 times 4 to the 3/2, 4 to the 3/2 is actually 8. So I end up having 16 minus 2. So my answer is 14. So that means the area under the curve, 3 root x, from 1 to 4 is 14. Okay, let's go ahead and look at this next one. Secant squared x. So I'm going to go ahead and utilize my integration rules. What is the integral of secant squared? You guys should have it on that sheet of paper. Okay, what's the integral of secant squared?
Sine.
Nope.
2 sine. Closer?
It's either like cotangent, secant, cosine.
Tangent.
The integral of secant squared is tangent. So I'm evaluating tangent of x from pi over 4 to 0. So I'm going to plug in pi over 4 so I get the tangent of pi fourths minus tangent of 0. Okay. So what's the tangent of pi over 4? It's the tangent of 45 degrees. Tangent of 45 degrees is 1. What's the tangent of 0? 0. So my value is 1. Okay, we've got one more problem to look at. And that's the one with the absolute value. So if you remember, absolute value was a little bit different. So what we need to do is we need to find where, in fact, the absolute value hits the x-axis. And so if I were to graph this, and I'm looking specifically between 0 and 2. So there's 0, 1, 2. I need to find where it hits the x-axis. And so the easy way to do that is to take 2x minus 1 and set it equal to 0. So where does it equal 0? 1/2. Okay. So now at 0, the value is going to be positive 1. Because if I plug 0 in here, I get 2 times 0 minus 1, which is negative 1. But we're actually taking the absolute value of it, so it's a positive 1. So now I know it's a mirror image, so I know it's going to equal this here. And then at 2, if I plug 2 in, I get a value of 3. So there's 2 ways to find this area. One, I could find it visually and just go ahead and draw in and find the area of each triangle. That's one way. The other way is to actually do it mathematically. And so mathematically, what I'm going to do is I'm going to split this into 2 integrals. And the first one is from 0 to 0.5, and the next one is from 0.5 to 2. Now, when you're doing absolute value, if it ever goes down, so like in this case, it goes down from 0 to 1/2. This is where you negate the whole function. If it goes up, the function stays the same. Okay. So I'm going to say that again to make sure we got that. If it goes down on the absolute value, you negate the whole function. If it goes up, you use the original function. So now all I'm going to do is find the individual integrals. So this actually becomes negative 2x plus 1. So if I integrate that, I get negative x squared plus what? Plus x, yep. And I'm going to evaluate that from 0.5 to 0. And then I'm going to add that to, in this case, x squared minus x, and I'm going to evaluate that from 2 to 0.5. So now let's plug in 0.5. If I square 0.5, I get 0.25. So negative 0.25 plus 0.5 minus 0. Okay, it doesn't matter where I plug 0 in, I'm still going to get a value of 0. Now from here, let's plug in 2. So here I'm going to get 4 minus 2 minus 0.5 squared, which is 0.25, minus 0.5. So negative 0.25 plus 0.5 is 0.25, plus 4 minus 2 here is 2. Let's see what we have here. And then this comes out to be minus negative 0.25. So So that will be plus 0.25. So your value should be 2.5. Now, if we want to check it, we could go ahead and check it and find the area of each individual triangle. The area here will be 0.25. How do I know that? Base times height divided by 2. The area here, base is going to be 1.5. Height will be 3. So basically I've got 1.5 times 3 divided by 2, which should be 2.25. You add the two areas together and you get 2.5. So it does match up. What you need to do then from this section, pages 291 through 293, 5 through 38, 47 through 50, and then 87 through 90.